Stretching out the sillies. Okay. Oh, good. Yeah. I hope you did that too. It's a good thing. Stretch them out, dance it out. Biogeography, talking about patterns. So evolution. Evolution is a huge pattern that shapes a lot of geographical, historical, sociological events in the human species, let alone animals. And evolution is driven by population pressures. So let's get into that. First of all, what is a population? Okay, it's a group of organisms. So let's take ducks, right? So there is a group of ducks that live in an area. They have the ability to interact and therefore interbreed, and they're in the same area. And as long as they can all interact, that's a population. Okay. Now, what happens if something happens where ducks on one side of the country no longer can interact with ducks on the other side of the country? Right? Something causes a break, right? Then you could have a speciation, because now you have two groups that don't interact. And over time, different population pressures may cause them to take different evolutionary paths. And that's called speciation, right? So a population pressure, what would that be? Or selection pressure. Things that affect your ability to basically grow and have babies. So animals that you eat or eat you, the amount of food in your habitat. Basically, anything that stops an animal from having offspring is a population pressure. And if it gets so strong you can't reproduce at all, then you have extinction. But the animals that find a way to get around those pressures, that can produce more offspring, have more babies, have a better chance of succeeding. And any type of genetic traits they have get passed on. So if the world is getting colder and colder and colder because of an ice age, and you have this one group of ducks that has thicker fat, which helps them keep warm, and another part of the ducks don't have the thicker fat. The ducks with the thicker fat are going to survive the cold better. They're going to survive more and have more kids, and those traits will be passed on. The ducks that had the thinner amount of fat, maybe they die of hypothermia faster. They still have children too, but just not at the same rate. But evolution will always select those that can produce the most offspring. Okay? So with speciation, if you have a group of animals and something causes them to split, either something in their range or a different trait, and all of a sudden now you have ducks in the north with a lot of fat and ducks in the south with a little amount of fat, now you've got two different species. Okay? And as far as we can tell, all the organisms on Earth have undergone this speciation. That speciation gives rise to new species, which further gives rise to new species. Okay? So let's kind of go through this in detail. More offspring are produced than the environment can support. A lot of fish, salmon, they lay 7,000 eggs per salmon. Now that's a lot of fish, because they do that because, well, in their environment, a lot of those eggs are either eaten, or they don't hatch because they get washed away, or when they do hatch, the small fish get eaten. So if a salmon lays 7,000 eggs, maybe only 70 get down to the ocean and grow, and maybe only 7 come back, right? So they've evolved to do that. Okay? Members of a population are unique, genetically unique. That is one of the benefits of sexual reproduction. You have two individuals, when they mate, they combine their DNA. Right? So you know that you have half of your father's DNA and half of your mother's DNA. So you are not genetically your mother or your father. And why is that beneficial? Well, if you are an exact copy of your parents, if you were a clone, right? If you had your father or your mother's DNA completely, that might work. But what if something happened in the environment where you needed to have maybe longer hair? For some reason that's beneficial. Longer hair helps you survive longer, right? Unless you have the gene for longer hair, you're not going to grow. It's not going to happen. But with each, generation of individuals that is reproduced sexually, you have a reshuffling of the genes, and maybe the gene for longer hair shows up, right? Or maybe something happens to cause that gene to emerge, some kind of mutation, right? And now you have this. So with sexual reproduction, you have more shuffling of the cards, if you will. You get a better chance for genetic variation. And why is that helpful? Well, let's go back to the fish. If the temperature of the lakes are rising, so global warming is raising the temperature of the ocean, okay? If you had fish that were exactly alike, they would never have a different gene for that. And if it gets out of their temperature zone, then they're dead. They can't adapt to it. But what if some fish, genetically, through reproduction, have maybe a gene that allows them to enjoy a little bit warmer water temperature? So they're a little bit more tolerant. Those fish are going to survive at a higher rate and produce more fish. The ones that can't adapt, that don't have the genetics to adapt, are going to die off faster. And if the pressure keeps on happening, eventually the salmon that can't tolerate the warmer water will die. And all that'll be left are the salmon that can tolerate the warmer water. And that's how evolution occurs. It isn't like there's this plan, I'm going to grow arms or legs or feet. It's more whatever genetic traits you have that allow you to produce more offspring than someone else. Evolution in the long run will favor that. Now in evolution, we have two interesting patterns, things that are convergent and divergent. And convergent is like its sound. You have two organisms that basically look the same or do something the same, but they may be completely different. But because the environmental conditions would favor those adaptations. So we look at these type of rodents throughout the world. These are three different species of rodents. This is the kangaroo rat, which is in the west coast of the US, the Egyptian gerbil, and a Central Australian mouse. So you got a mouse, a gerbil, and a rat. Now they are all rodents, but they're different species. But what do you notice about them? Right? They all have very long legs, right? Look at these little long legs here, and really long tails, right? So what happened was they all live in hot, dry deserts. And these long tails, they act like a radiator. Because they're long and they have no hair, they can pump blood through it closer to the skin, which allows it to cool off. So in a desert environment, that's very helpful. The long legs, they help keep you off the hot sand, help air you out. And again, longer limbs in a hot climate helps you basically release heat. So living in a desert environment caused all three of these to evolve the same. Another example would be sharks and dolphins, right? One's a fish, one's a mammal, completely different species. Yet they both have that kind of streamlined look with the flippers and the fins, because if you live in the water, that just is much more effective than having maybe hands or legs, right? I mean, dolphins are actually more closely related to cows than they are to sharks. So that's convergent evolution. Right? Another example are plants. These are two different species of plants. This is actually a form of a tree, and this is a cactus. One's in Africa, one's in South America, but what do you notice? They have no leaves. In fact, their leaves are those tiny little needles, right? They have that kind of cylindrical shape. And why is that? Well, with those little tiny needles they have, that stops animals from eating them, because their kind of round cylindrical bodies there are basically big sponges. It allows them to absorb and hold water, so that the very little amount of rain that they do get in the desert, they can store it like a big sponge. Well, that's very attractive to animals, and so they evolve these little tiny thorns that a cactus or a desert tree has to kind of stop that. So divergent evolution is different, and this kind of leads to most of the species that we have. This is when you have a population of an animal, and something happens where it gets isolated reproductively. In other words, one group gets separated from the main population, and they don't interact. And that separated group then evolves, and they adapt to their new environment. So let me show you kind of a thing here. The common rosefinch, this little tiny bird, very common throughout Siberia, Eurasia. Somehow, a population got to Hawaii hundreds of thousands of years ago. Maybe it got blown in a storm, or it was able to wash on a piece of wood or a tree or whatever. But they get to Hawaii, and now this bird's called the iwi, and you can see much different. Big, longer beak, redder, lever favors. And what happens? You have the original population, which is still, by the way, there in Eurasia today. But a small group somehow gets to Hawaii, which is 2,000 miles away from anything else. So they're not interacting with this group anymore. And they begin to evolve. And one of the things that shapes the evolution is the way they eat. So some of the birds eat insects, and they drink nectar from flowers. Well, a beak that is long and narrow favors that, because you can stick it into the flower, you can use it to stab the insects like a little stick. So over time, get my cursor to work. Rose finches that had beaks that were a little longer and narrower, right? So they had some kind of genetic trait. Those were favored, and they were able to eat more insects. They had more food. They could reproduce more often. So they had successful offspring. And over time, they got these big, long beaks. But some of the birds found that they could eat seeds and fruit. Now that's a different beak. It's kind of a short beak. It's more powerful for crushing open the seeds. So you can see they kind of get this right here. These birds all evolved from one type of bird. Okay? So divergence is tied to dispersal, right? And dispersal is where an organism basically is separated or moves from its original area, right? So a population splits and one is dispersed, okay? And what happens is, if you have that dispersal, and if it's great enough over time, the two groups no longer interact. So in other words, if they don't interact and don't mate, they may be the same species, but if they're not actually, if there's birds in one part of the Pacific Ocean and birds in another, they may be the same species for now, but if they're not able to mate anymore, they're going to diverge over time, okay? And that is divergent evolution. All right. Trust me, I know evolution can kind of be a controversial thing. I'm not glossing over this whole debate that people have about evolution and religion, but that is something that we'll talk about with your discussion questions. So keep those thoughts for now if you have that. And we'll be back with part 3 as soon as I get up and stretch.